everybody, dear judges. We are from Bach Khoa Math and Science Club from Hanoi, Vietnam. Today we're going to talk about our smart garden with temperature and moisture sensor using solar energy. First, about our introduction. The reason why we're having this project is that many mountainous areas in Vietnam have no electricity or difficult to supply electricity. Other obsolete irrigation systems are mostly our setting, which is not convenient. For example, this one, watering time controller. We aim to design an automatic vegetable irrigation system using solar energy with two sensors, which can be installed anywhere, even in high mountains or remote islands without national grid. Here are some of our detailed goals. It can be installed everywhere, can be used without electricity, time-saving, easy to use, and consume small amount of energy. The significance of the project. This project helps students be interested in science subjects, the necessity of saving water, and better care for plants.
This machine uses a solar panel, two circuits. One is for operating the moisture sensor and one is the temperature sensor. It has two pumps. One is the moist pump for the air and one is the water pump for the plant. Each plant output, this is for the hose for the tree in the soil, and for cooling the air we have this moist spraying valves up here. The machine will read the temperature from this sensor, which will feed it into this module. If it is below the if it's higher than the minimum setting on here, it will turn on the spraying valves for the water. This is the moisture sensor. This board will read it, and if it is below the minimum moisture requirements, the relay will turn on and it will pump water into the plant.
You can see that when the soil moisture is low, the drip irrigation automatically turns on, and you can see all the temperature and the moisture on the top right corner. You can see that we are increasing the temperature of the environment. When the temperature increases to above the default setting, mist sprinkle will be automatically turned on, and it will be automatically turned off when the temperature falls to the desirable point.
I'll talk about the result of the experiment. About the output, first it uses solar panels to generate electricity. Secondly, it consumes small amount of energy, and finally, it can be installed everywhere. Our system achieves 5 out of 17 Sustainable Development Goals of the UNDP. First, no poverty. Secondly, it's affordable and clean energy, decent work and economic growth, responsible consumption and production, and lastly is life on land. The last part is the conclusion and recommendation.
Advantages and disadvantages of the system during experiment. Advantages: stable operation and high reliability. In terms of usage, the machine is easy to use, compact controller, modular design. Common device, easy to repair and replace when damaged. Low cost, suitable for Vietnamese agricultural condition. Environmental friendliness. About the disadvantage, the system cannot measure other plants parameters such as pH concentration, light intensity, real time.
Our recommendation is that we should input parameters and pH concentration, real-time light intensity to make the best optimal algorithm for plants. IoT allows users to control and monitor the system remotely. Thank you for listening.